What is this?
Automatic control.
Does it throttle?
Yes.
Yes, it throttles. Is it fell open or fell closed?
Those.
How can you tell?
Air
From the bottom.
Okay. What is it?
PRV.
Which stands for?
Pressure relief valve.
What's the purpose?
Relieve pressure.
Pressurization.
So this spring is going to be set at a certain resistance. Let's say 50 PSI. Once it reaches 51, what's it going to do? Does this one open suddenly or gradually? Gradually. Okay, good. That's why it doesn't have the hand wheel for you to have to reset it, right?
Yeah.
All right, now we're going to look at this one. What's this one?
PSV.
For vapors or liquids?
Vapors.
Okay. Suddenly or gradually?
Suddenly.
That's why it has the hand wheel. So the safety will have the hand wheel because if it slams up, you can reset it using the hand wheel because it opens fast. Okay? All right. Or that one. What's this one? What kind of valve is it?
Gate valve.
Most common valve used for what?
Open close.
Open close.
Why isn't it designed to throttle? How do you know? It'll erode. It's not beveled, right? Any valve that has a beveled internal can be used for what?
Throttling.
Good.
Swing check.
Check valve. Check valve. Check valve.
What kind of check valve?
Swing check.
All right, what's its purpose?
To prevent backflow.
Prevent backflow? Does everyone know that? Y'all did the intros of class, can y'all see?
We just did a microfill on it.
What is it?
Swing check.
Swing check. Prevents.
Backflow.
What's this one?
Globe valve.
Flow valve, is it beveled?
Yes.
You can throttle with that one, Misty.
It throttles. Throttle.
What's it designed to do?
To throttle.
Throttle.
Which one of these is the most commonly used for throttling? Okay. What's this one?
Butterfly.
Butterfly.
Looks like it has wings, right?
Yes. Yeah.
Says it can be throttled, but what is the negative? I don't think this is in the book. What's the negative about having butterfly valves, using them as isolation points?
They leak.
They're the most likely to pass. Look at how much of a seat it has, all the way around the internal of the equipment, right? So if anything's in there, when you go to close it, it's getting trapped. They're the most likely to leak, okay? What's this one?
Ball valve.
See it? Alright.
Ball in there.
What's this one?
Plug.
Plug.
Needle.
Can you use it for throttling?
Yes.
Yes.
Everyone agrees?
Yes.
See it beveled?
Yep.
Check that.
Spring check? Ball check? What's this one? XV. So this one is motorized, so they don't necessarily call it an XV, but if it was pneumatic, it'd be an XV. What kind of body does it have?
Ball.
Used for
No, on off.
open, close only, right?
Yep.
I love you, man.
Rupture disks.
When are they used? What are they used for?
Relief, pressure relief.
If you overpressure, boom. I wouldn't say boom, I'd say pop.
You heard what it is?
Orifice.
Blind.
Sure
Blind.
about that?
That's a
That's a
Blind.
blind. Paddle blind? Okay.
Orifice plate.
No jokes, we videoing.
No, that's a blind flange, but it's a you just keep it in there.
Spectacle
Oh.
or figure eight.
Oh yeah.
So this stays in. If you see this part sticking out the pipe, you know what's in. Paddle. If this is inside the pipe, this will be hanging out. You have your paddle blind in. When this side's in, it's just a spacer. That way, if you need to do an isolation, you can flip it.
Yes. Plug.
Plug.
Do I need to pull it off, or I can just point?
Cap.
Cap. Y'all are. Class ain't answering like y'all were.
Come on, fellas, move in. Move in, Pat. You can see from here. Is it a nipple?
Nipple.
Yeah, that's a nipple. Nipple.
Nipple.
Union.
Union. Reducer.
Bushing.
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 Bushing. That reduces the.
Orifice. Column. No, none of that, son.
We're not playing right now. Coupling?
Coupling.
Bell reducer.
Reducer.
Elbow. T.
Y.
Why what?
Strainer.
This is the strainer that goes in the Y, right?
Yeah. Straight up.
What's this?
Flange.
What type?
Threaded. Non-threaded.
Blind flange.
Line.
What do operators use fittings for?
To connect
Pipe.
Hoses, connect hoses to what?
Purge and.
To bleeders?
Later.
Okay. Blind flange, so you remove it. The flange is this size. It's fine.
You need to open this.
This is staying in the video.
My hands can't. Using your fittings in your blue boxes, figure out how to connect it. So that way we can bolt up this flange to the flange on the bleeder.
Pause the video.
Stop, Pat.
That's beautiful.
How'd you build it?
That's going on. Okay, how does it work?
The impeller will spin and it will suck liquid into the eye and use centrifugal force to push the liquid out through the discharge.
The centrifugal force.
What's this?
Bearing housing.
What's the purpose of it?
Keep your bearings lubricated.
What's the purpose of your bearings?
Keep your shaft from moving.
Vibrating.
Which bearing is the one on the outside?
Axial.
Which one, which is also referred to as what?
Thrust.
Which one's on the inside?
Radial.
What's the difference between a PD pump
Positive
and a
displacement.
centrifugal pump?
Positive displacement gives a certain amount of liquid each time, or product
Each time. What do you mean by time?
Each time it
Each
strokes.
Okay. Or thrust or whatever it is, whatever
Yeah,
type.
one of them.
Okay. Why are centrifugal pumps way more common and popular than positive displacement pumps?
Because they come. Less pressure.
Get the fuck away.
How many rotating parts or moving parts do we have in here?
A lot.
Last longer.
Okay.
Patrick, get the
How many moving parts do we have here?
Very few.
Less.
2?
There's less things that go wrong.
Okay, so less stuff to break, less things to go wrong. But with centrifugal pumps, can you control the exact amount that's entering something?
No.
No. With a PD pump, positive displacement pump, you know that every rotate or every stroke, you are injecting the exact amount at the chamber, right? Now, a variable speed PD pump or a variable speed centrifugal pump, with a PD pump variable speed, you can adjust the speed of the stroke and the depth of the stroke in some of them. Don't even think about it, Jimmy. All right. Centrifugal pump, how much it's discharging, right? The flow is going to be dependent on the pressure of the discharge, right? With a PD pump, the flow is going to be dependent on the size of the chamber. So you use a PD, what system, type of system? Can you give me one example of a system you would use a PD pump over a centrifugal? Reactors? Why? Because you know exactly how much you're putting in, right?
Yeah.
Or like in the hot unit, you have that chemical injection pump.
Yeah.
That's for antifreeze.
Oil reservoirs.
You want a perfect composition, right? You know exactly how much you're pumping in. Centrifugal, you don't.
Move air.
Air? Only air?
Vapor.
Vapors or gases, right? Which includes,
Air.
but only your instrument air compressors are really going to be used for air. Alright, do we have, in order for flow to happen, what do we have to have? Difference in pressure. Is it gonna go high pressure, low pressure, or low pressure to high pressure? Okay, so in order to move gases, we gotta have pressure, right? Or we may just need to boost the pressure for a specific reason. Okay, when it comes to rotating equipment, the higher, entering and exiting rotating equipment, the higher pressure side is gonna be what in pipe diameter compared to the other? So which one is smaller? Alright, and if the purpose of the compressor is to increase the pressure, where is pressure going to be highest, on our inlet or our outlet? Discharge, okay. So which ones are discharge? Suction, discharge. This little 3D printed one does not explain it thoroughly, right? We all know that?
Right. Correct. Where's JT?
No. Alright, so we got our suction. It's going to go in. It's going to go to the first, what do we call it? Each set. Stage. How many stages are on this one?
6.
Let's count together since y'all know how to count.
1,
2,
3,
4, 5, 6, 7.
Okay. So it's going to go in. Works the same way. A centrifugal compressor works similar to a centrifugal pump, right? I've never seen a single stage centrifugal compressor. Most pumps are single stage. So it's going to go in. It's going to use centrifugal force, right? To increase the speed. And then when it's forced through the smaller channel, it's going to convert that speed to pressure. And by speed, I mean velocity, which is speed in a specific direction, right? Okay, but before it goes to the next stage, we know that what happens, how does pressure affect temperature?
Higher pressure, higher temperature.
Higher pressure, higher temperature. So is it going to be hotter here?
Yeah.
Okay, and how does temperature of a gas affect its viscosity?
And gas is more viscous.
More viscous because it likes to expand, right? So we're going to go through an intercooler.
Yeah.
Alright, and the intercooler is going to decrease the viscosity, right? And we know viscosity is what? A fluid's resistance. Okay. And then what if there's any moisture that condensed in that intercooler? It's going to go to knockout drum, which does what? Knocks out liquids, right? Good. And then it can go to the next stage. And in between each stage, that process will repeat, okay? Then when it comes out, where's it going to go? After cooler, and then another. All right, and what's always upstream before it enters? Knockout drum. Got to protect your compressor from liquids. If not, it'll cause surface pitting. Think of walking in the rain versus Daytona 500 in a convertible while it's raining, right? Okay. What? Where the shaft is, what's actually making this rotate? Okay, and what are the two most common types of drivers in our local industry?
turbine and electric motor.
Turbine, electric motor, and what two types of turbines are most common?
Steam
and gas. Okay.
Exploding and non-exploding.
What's happening to the pressure of our steam as it goes through the turbine?
It decreases.
Going down.
Decreases?
Yeah.
Okay, so we've got high pressure steam going in.
Yeah.
Yes.
Where's our smallest type?
Inlet.
Which
Right
one's
under
that?
Point to it, Holly. Show them what you got.
What is this?
the regulator.
Trip and throttle.
Trip and throttle? What's this?
Your linkage, well, your manual trip.
Your trip. Okay.
Governor.
Governor.
Linkage.
Linkage. How does that work? How does your linkage work? Or your governor work? To control, it controls what?
Speed.
By controlling the,
Inlet.
how much steam is entering, right?
Right.
Okay. So, this is going to be going like this. It's janky on this one, but this would actually be going in and out. And it's blocking your flow in here. Okay? So from there, we have, I'll do it on this side. We have our, which bearing is it? Axial. Someone the other day taught me a trick that on how they remember it. This is your rotor, right?
Yeah.
Okay, so your radial is closest to your
Rotor.
Yeah, it's a good trick, huh? All right, and this is our
Swing
sling ring.
ring.
How does it work?
Picks up oil.
Does it sling it? Okay, so your slinger ring actually grabs it and goes side to side and lubricates your bearings.
Yes, ma'am.
Let's look over here.
Let's get an example.
Oh, Lord. We're not supposed to run that without supervision.
Looks like it's slinging some up.
That's a different one. You see what it's doing? It's lubricating side to side. Right?
Really? We loaded everything back in here.
Okay. Alright. So that's, the slidder ring is in between each bearing, right? And so it'll pick it up and side to side. Okay, from there, what are these? Carbon rings, which are seals, okay?
Made out of.
So,
Hydrocarbon.
turn it sideways, maybe you can see. Well, let's go through it. So your steam comes in, goes to your steam chest, right? It's gonna go through your nozzle block, which is gonna direct your steam flow. And then it's going to these buckets or chevrons, depends on where you work. They may want you to use the proper terminology, but a lot of people say buckets. Okay, so it's gonna catch, you can actually, they're hollow, like it'll be a chevron and then another one right under it, but the steam can go in between them fully, okay? So it's gonna catch it and spin it, right?
Yes, ma'am.
All right, and then what spins when it spins?
Shaft.
Okay, and that shaft will be connected to what?
A pump? Or anything?
Whatever it's driving.
Whatever it's driving.
Whatever it's driving, so that could be a pump, a compressor,
Your mom's
or
coming
get the blooper. All right, a pump, a compressor, or a what? Generator? Generator, all right.
What is a generator?
Okay, now,
I got an 87 on Benetton.
you don't always have a letdown and an exhaust.
Shit like that.
In this one you do. Okay, so your letdown goes half a rotation, right? Your exhaust goes a full rotation, right? So which one is going to be higher pressure?
The exhaust.
No, you're not going to be saying it backwards.
Blooper.
Your letdown only uses half the amount of energy because it only goes through half a rotation, right? Your exhaust uses more energy because it does a full rotation, right? So, which one's going to be higher pressure leaving? Your letdown or your exhaust? Letdown. So, higher pressure we know is going to be thicker pipe or thicker, thickness.
Oh,
Not talking
thicker,
about
yeah.
diameter. Talking about thickness, the rating of pressure. What's it going to be?
Thicker.
Higher pressure is going to be thicker. So, which flange is thicker? On
Right one.
outlet or exhaust?
Right one.
Which one?
Right one.
Right
This one?
Yep.
Yes.
Okay, so what's that going to be?
Let
Let
down.
down.
And this one's the smaller one? So what is it going to be?
Exhaust.
What's this?
Bearing housing.
Okay, one of y'all got it.
Bearing houses.
Bearing housing?
Bearing housing.
Alright. What are these lines? Cooling water?
Yeah.
Okay. What's something you should check on it when you're making rounds?
Leaks, oil
Check the
levels.
temperature difference? Yeah?
Mm-hmm.
If there ain't much of a temperature difference, what's that mean?
Ain't working.
Yeah, your cooling water ain't cooling. What's this? Sentinel, what's the purpose of it? It's not, it's an alarm, pretty much. It's gonna, if it release pressure, it's gonna, right? No, I'm fine with you chiming in. So it's gonna alert you that you're overpressuring. What is the most common trip?
Overspeed.
Overspeed. If you get a call saying you got an overspeed trip, what's the first thing you'll want to check in the field?
Coupling.
Coupling, right? So you'll have one end attached to your driven set shaft, right? You see the teeth in them? Those will be together, and then this would be on the other shaft, and it would fit perfectly with the teeth, right?
Oh, yeah.
Why would you check your coupling?
Because if that broke, you're only spinning the dryer itself.
Yeah. So if your coupling broke or shredded, right? So this would be an example of it shredded, the teeth being shredded. There's no resistance of what's being driven. Now the steam's just turning this right, to here,
It's not doing nothing.
and it's not driving anything. So there's no resistance, so it's gonna start going way faster, right? Hence the overspeed trip. What type is it? Fin fan. How does it cool?
Ambient air.
There's a fan at the top and it blows ambient air, right? You got your tubes. And then you have fins directing the airflow, so that way if you have a windy day, it's not just taking the air and moving it.
YouTube heat exchanger.
YouTube heat exchanger.
Thermostat.
How do you know which side's your tube side? What's this? Well, these are the bolts for your channel head. Your tubes are always going to be on the outside of that, right?
Bless you.
If it's a single pass, meaning it goes through, comes out, you'd have another channel head over here with your tubes come out downstream of the bolt. Okay? Heat exchanger rule of thumb, if it's cooling water on your tube side and oil on your shell side, you heat something down.
Heat it up.
Okay, so if it's getting cool, if it's going in cold, we know it's coming out
Hot.
hot or warm, right?
Warm.
So is the cooling water that's going in cold getting heated up or heated down?
Heat it up.
So it'd go from bottom to top. Right, now the oil is getting cooled by the cooling water, right? We're transferring heat.
Correct.
So it's getting cooled
Down.
Down.
not cooled up, right? That's not a thing. So where's our inlet gonna be?
Top.
Out the bottom. Okay.
Hey, got a question.
We were talking about this heat exchanger. We're talking about cooling water. What are some things that? What are some issues that come from having water going through our exchangers?
Scale.
Scale. Right. What is scale?
Build up.
Okay. So
Good example.
what is this?
Tubes.
Look at it.
Scale.
Can y'all see it? Can y'all legit see it? Okay. How's that gonna affect your exchanger?
Clog it.
It's gonna restrict flow. So what's gonna happen to your pressure on the inlet? Pressure on the outlet?
Decrease.
Pressure or differential pressure, the difference in the pressure.
Increase.
Alright. It also acts as insulation. Remember? Okay, so what happens? Are we gonna get heat transfer that we want between our tube side and our shell side?
Nope.
So what's gonna happen to the temperature coming out?
It's gonna be cold and then you want it,
On our shell side, right? Colder.
yeah, hotter on it,
No, on your tube
no,
side.
on your tube side.
On our tube side coming out, it's not gonna absorb the heat, right? So it's gonna be closer to the same temperature. And then our shell side, same concept. We're not gonna be able to lose heat because, so our difference in temperature on our inlet and outlet, aka our delta T, is gonna be what? Lower. Okay, good. Back flush. So what are we gonna do? What are we gonna close? The isolation point for the
Suction.
inlet
Inlet.
of the tube side. If our cooling water's on our tube side, right? We're gonna close the inlet on our shell.
Two.
We're gonna close the inlet on our tube.
Yep. Correct.
And then what are we gonna open?
Butterfly valve.
The butterfly valve or the drain valve, drain line
Suction.
on the inlet, right? Downstream of
I say
the isolation point. Okay. And so, what kind of exchanger is this?
single.
Oh, I stumped y'all on something. Okay. This is a multi-pass. Okay. So, flow would be coming in here, right? Can it get to these tubes right now? Or on this side of the baffle? Can it get? No? Alright, so it's going to go through these tubes.
Yep.
Okay, where's it going to go next?
Into that.
Under the other side?
Yep.
Okay. Where's it going to go next?
To the other side.
To the bottom?
Yep.
Okay. And then where?
Out to the bottom, other side.
Then to the other side, back to, and then to the
And then
other
where?
side.
Out that outlet.
How many passes is that?
4.
1, 2, 3, 4. Thank you.
Yes,
Alright.
ma'am. Kettle boiler.
Ms. D, what'd you call it?
Multi-pass.
Kettle boiler.
What kind is it?
That's a steam generator.
Where is our shell side? Is our shell side inlet liquid or vapor? Liquid. Okay, where does it enter?
Your right hand.
This one?
Yeah.
Y'all see that?
Yep.
Why would it not make sense to enter here? Because your level plate. So this plate keeps your tubes fully submerged, right?
Correct.
So it's going to fill up, and then once it reaches above this, it'll overflow.
Yep.
Why is it shaped like this? What is this room for?
Vapor space.
Vapor space. It's room for boiling, right? What's this going to be?
Vapor.
Your vapor outlet. You know what it actually, a lot of people refer to it as? Burp up. Okay, so you ever burp up or have acid reflux?
Yep.
It's mostly gas with a little bit of
A little bit of shit.
liquid. Blooper. A little bit of liquid.
Yep.
Okay, so can you imagine boiling a pot of water? Okay, and the bubbles of the water
Yep.
or the top skimming that. That's what's filling this up and coming out right here. So there is liquid returning to your distillation column through it, the outside of the bubble, right? What's casing the vapor in a bubble. Okay. All right. If this is a kettle reboiler, right? You know what they also can be used for and referred to as?
Steam generator. That's what they told us.
Maybe I just don't know about it. But what else? What about in cryo units?
I don't work in there. I've never worked in an LNG.
You never worked in a nuclear.
You tell me.
All right, so it could also be referred to as a chiller, and so you'd have propane on your shell side. You'd be cooling your process, and as the process heat is absorbed by the propane on the shell side, it's gonna boil or vaporize and get sent back to get cooled again. So your cooling process will be on your shell, coming in, overflowing, whatever doesn't flash off, going to get sent to get cold again, condensed, coming back to cool your process on your tube side. What's this one?
Loading head.
Floating head.
Floating head.
Everybody?
Floating head.
How can you tell?
The head floating. Float,
How many heads does it have in there?
Chill, bruh.
So your tube side has a head too. What are they used for? They're good for what? Our inlet and outlets are missing right here.
Exchanging heat.
Less thermal shock. Okay, your tubes can expand. Your tube side can expand when it goes into the smaller head, the tube side head. Plate frame.
Yep.
How does it work?
Pretty solid.
Between each set, you're gonna have a hot flow going through a set of plates, right? And then the next set of plates, or the opposite side of that plate,
Cold flow.
cold flow, and then
Hot flow. Cold flow.
and there will be gaskets that will actually be allowing the hot, so the hot side, cold side, and there will be gaskets either there or not there to allow the flow to come down from each plate.
What PSIA?
The removal of,
Atmospheric pressure.
okay, so on a PSIA scale, below what number would be considered a vacuum?
14.7.
Yeah, how do we know the difference between PSIA and PSIG?
It says PSIA accounts for atmosphere.
PSIG includes atmospheric pressure.
Yeah, so PSIA stands for pounds per square inch,
Absolutely.
absolute, but my trick is the A stands for atmospheric because it includes atmospheric pressure. Don't ever tell anyone that unless you're telling them the trick because you're going to sound stupid. Okay, and PSIG, what does it stand for?
Gauge.
Pounds per square inch gauge. Okay, does it include atmospheric pressure?
No.
No, so 14.7, right? Okay, so what number would be considered a max vacuum on a PSIA? PSIA.
Zero.
0. You can't pull more than atmospheric pressure out, right? Okay, PSIG
Negative 14.
would be a max. Okay, and below what number would be considered a below 0? Okay, and which one would you use if you had a vacuum system? PSI A or G?
A.
Okay. How does pressure affect a liquid in an enclosed vessel? Lower pressure?
Are you about to boil water?
You should have put ice in there.
I don't know. This thing's so.
That thing's a piece. When we tried this last time?
Last time it didn't work.
Everyone's been Rupture Disks.
It popped me.
Oh my god, I can see it. Oh my god.
It won't let me. Okay, y'all see the bubbles starting to come? It should explode, like burst into boiling soon.
There you go.
Alright. Y'all want to have a little fun with it?
Yeah.
We're having a serious class, bro.
Did y'all do this in fluids?
Alright.
Alright, cooling tower, the purpose of it is to do what again?
Cool water.
Alright. And then the water goes where? Heat exchangers. To do what? Cool
Cool the
process. Alright, in order to cool the process, the heat has to go somewhere, right? Where does it go?
The water.
The water absorbs the heat, right?
Yes.
So now the process is cold, but the water is hot or warm. So then the water is going to go back where?
Tower.
To the cooling tower, right?
Yes, ma'am.
Alright, it enters the what? The cooling water enters the what?
Distribution header.
Alright, which is going to distribute it, right? And then you have the...
I didn't say
Oh,
shit.
the tray at the
His
top.
stupid ass is talking.
Not really one, but it has the distribution nozzles
Yeah.
that come out the
That pour
distribution
out.
nozzle,
It's got a
right?
tray that feeds it into.
It does have a tray, huh?
Yeah, it does.
I don't
Look at
know.
the top of the thing. Of the tray.
This one does.
That's a
Oh.
that's a realistic one right there.
Yeah, I've
That's
seen
how
some
they
of that
look.
size on
Okay,
the planes.
alright, y'all.
They actually did have them out there. I bet.
Alright, so it goes from the distribution header to the
Yes, ma'am.
distribution nozzles.
Yes, ma'am.
Think of it like fire sprinklers, right? And then it's gonna go over the what? Which does what?
Any surface areas.
It breaks it up into what?
Small droplets.
Small droplets to increase the,
Surface
Surface
area.
area.
so that way the more wind can come in contact with more water, right?
Wind? Is that
Air. Yeah, it's kind of wind.
Is it
A
called
fan
wind?
makes a wind. Air.
Absolutely.
Yes, it maximizes heat transfer when you increase the surface area because you have more contact between the water droplets. Okay. What's this right here?
Drift
The middle
eliminator.
Drift eliminators. What do they eliminate?
Eliminates drift.
Yeah, any water droplets from getting sucked out the fan at the top. If the fan's at the top, what kind of fan is it?
Induced drift.
Induced draft. If the fan was at the bottom,
Force.
okay. If there's a fan at the bottom and the top,
Balance.
Balance.
and then if there was a fan, no fan. Natural. All right. What are these?
Louvers.
Louvers. What do they do?
Direct airflow.
Direct airflow. Okay. And then the water, by the time it gets here, is cool.
Basin.
Basin. Okay.
Blow down.
And then the lowest point of the basin is going to have a what?
Blow down.
Blow down line, which does what?
Blow down.
Remove
That is
solids.
true.
Removes any
Solid.
dissolved solids, algae, etc. Right?
Sticks.
And then on the edge of the basin where the piping goes to the suction of the pump, what are you going to have? Strainer. Or screen, more so.
Screen.
Okay?
We ace this shit.
How does a cooling tower...
Evaporation.
Cooling tower cools through evaporation. I know you can't see it on the video, but you can actually see the moisture leaving the top of the column. You can see it kind of building up in here. And then where does it go from the basin, from the pump?
Out.
To the heat exchangers.
Yes,
To
ma'am.
cool the process, and then where does it go after that? Back to the
It's a
cooling
closed loop
tower.
system.
Good.